Hello and welcome to the video on sections 34.3 and 34.4 on solving multiple absolute value equations and solving absolute value inequalities. For multiple absolute value equations to be equal, the expressions inside the absolute value bars must be equal or equal to the opposite of each other. In our example here, we see that the absolute value of a plus b equals the absolute value of c plus d. For those to be equal, a plus b must equal c plus d, or a plus b must equal the negative of c plus d, or negative 1 times c plus d. When working this second equation, make sure you distribute that negative to both the c and the d. When dealing with inequalities, it is important to remember which inequalities result in an OR equation and which will result in an AND equation. The less than or less than and equal to will translate into an AND problem, and the greater than and greater than or equal to will translate into an OR problem. An easy way to remember this is less than. You can say it is less than, so you know it's an AND problem. And the greater than problems can be pronounced greater than. So that way we know they're an OR problem. Let's move on to some examples. First example, absolute value of 2x minus 6 equals the absolute value of x. So as we learned earlier, we need to set these up into two separate equations. So we're going to have 2x minus 6 equal to x, or 2x minus 6 equal to negative x. When I work out the first problem, we're going to subtract x from each side. So we're going to get x minus 6 equals 0. And when I add the x to the negative 6, when I add the 6 to each side, we're going to get x equals 6. On the second, we're going to need to add x to each side. So I'm going to get 3x minus 6 equals 0. When I move the negative 6 over, I'm going to add it. And then now I divide by 3. So I get x equal to 2. So I have two answers for this equation, x equals 6 and x equals 2. Now we can plug both of these back in to figure out if we are correct. If I plug the x equals 6 back in, I get 2 times 6 minus 6 absolute value equals absolute value of 6. 2 times 6 is 12. 12 minus 6 is 6. The absolute value of 6 equal the absolute value of 6, and we know that's correct because they both are 6. If we look at the 2, get the absolute value of 2 times 2 minus 6 equals the absolute value of 2. 2 times 2 is 4. 4 minus 6 is negative 2. And we know the absolute value of negative 2 is equal to the absolute value of 2 because they are both 2. We'll look at example number 2. Our two equations are going to be 5x minus 2 equals 2x plus 1, or 5x minus 2 equals the opposite of 2x plus 1. When I work the first problem, I'm going to subtract 2x from each side. get 3x minus 2 equals 1. Now I'm going to add 2 to each side. I get 3x equals 3, so I know x must equal 1. My second equation, my first step, is I have to distribute this negative on the right side of the equation to make it negative 2x minus 1. So now my next step is to add 2x to each side, so I get 7x minus 2 equals negative 1. And now when I add the 2 to each side, I get 7x equals 1. So we know x equals 1 over 7. So those are my two answers. You can go back, plug them in, and always double check your answer. Problem number 3. I have x plus 3 equals x minus 5. So we're going to have x plus 3 equals negative x minus 5 as well. The first problem, we're going to subtract x from each side, and when we do that, we get 3 equals 5. That is not a true statement. So on this side, there is not a solution. On the right side, I'm going to get x plus 3 equal to negative x plus 5. And I don't need that parenthesis there, so let's get rid of that. And it looks like I erased too much. So we'll go ahead and refill that in. So I have x plus 3 equals negative x plus 5. So when I add x to each side, I'm going to get 2x plus 3 equals 5. Now when I subtract 3 from each side, I get 2x equals 2. And so then I know x equals 1. So on this problem, we only have one answer. And we can plug that back in and check. This one's simple. 1 plus 3 is 4. 1 minus 5 is negative 4. The absolute value of 4 is equal to the absolute value of negative 4. Let's get a couple more examples. So on number 4, we're going to have 3x minus 6 equals 6 minus 3x, or 3x minus 6 equal to the opposite of 6 minus 3x. So the first one, when I add 3x to each side, I get 6x. And when I add 6 to each side, I'm going to get 12, and x equals 2. On the right side, the first thing I have to do is distribute the negative on the right-hand side to get a negative 6 plus 3x. When I do this, I can see that I have the exact same thing on each side. I have 3x minus 6 equal to 3x minus 6, which means I'm going to have an infinite number of solutions. So my answer would be all real numbers. So let's look at number 5. Here we're dealing with an inequality. Excuse me. We have x is less than, the absolute value of x is less than 3. So as we were told earlier, anytime we have a less than, that is going to be an and problem. So I'm going to have x is less than 3 and x is greater than negative 3. When I make the right side of the equation negative, I need to flip the sign. Always remember that. So when I look at this graph, so I'm going to have a negative 3 and a 3. I've got my 0 there in the middle. So anytime that x is less than 3, we're going to use a parenthesis since it's just a less than. and we're going to go towards the 0. Now if I look at the x is greater than -3, I'm going to have a parenthesis on the -3 and go to the right since it's greater than. So now I look at where my where my graphs intersect, and it's going to be the portion in between the parentheses. So my answer on this graph is going to look like that. Now to write that into interval notation, we write it just as it's graphed. It's going to be a parenthesis, -3, comma, 3, parenthesis. So let's look at number 6. I have x is greater than 3. The absolute value, of x is greater than 3. So I get x greater than 3. And since it's a greater than, it's an OR problem. And now we're going to have x is less than -3. So just like we did on the last problem, we're going to try to graph this one. So I have my points at -3 and 3, 0 in my middle for my reference. So anytime that x is greater than 3, you have a parenthesis and greater than. Now we have x is less than -3, so I have my parenthesis on the -3, and I'm moving it to the left since it's less than. Or you're dealing with an OR problem, so we don't care if they intersect, we just want everything that the graph touches. So as we can see, the graph touches everything left of -3 and everything right of +3. To write this into interval notation, we write it just as it's graphed. We're going to -infinity on the left side. Anytime we have an infinity, it's met with a parenthesis. So we have parenthesis, -infinity, comma, -3, in parenthesis. Then we are going to combine that. So we're going to use the union symbol, the U, parenthesis, 3, comma, infinity, parenthesis. So let's look at our next example, number 7. We have x is less than or equal to 5. So I'm going to have x is less than or equal to 5. Since we're dealing with a less than, it is an AND problem. And x is going to be greater than or equal to -5. So let's look at a graph for this one. So I'm going to have my -5 and my 5 with my 0 for reference. We state that x is less than or equal to 5. So we're going to use a bracket, and less than is going to move to the left. Now x is greater than or equal to -5. We're going to have a bracket, and greater than is to the right. And we can see where we intersect. And it's right in the middle. So if I write this in interval notation, write it just as it's graphed from left to right. Bracket, -5, comma, 5, and a bracket. Let's look at the last couple examples here. So I'm given the absolute value of x plus 2 is less than or equal to 4. So my first equation is going to be x plus 2 is less than or equal to 4, and it's less than, so it's an AND problem. My second equation is going to be x plus 2 greater than or equal to -4. Remember, we flip that inequality sign when we make the second equation negative. And let's solve each of these. So we're going to subtract 2 from each side, so x is less than or equal to 2. And we're going to subtract 2 from this side and get x is greater than or equal to -6. When I look to graph, if I can make an arrow, there we go. So we have a -6, a 0 for reference, and my 2. So the left equation, x is less than or equal to 2. So I bracket on 2 and I go less than. And then I have x is greater than or equal to negative 6. So I'm going to bracket on the negative 6 and move to the right, which is greater than. I'm dealing with an and problem, so I'm going to want their intersection, which is between the two brackets. So if I write this in interval notation from left to right, bracket negative 6, comma, 2, bracket. Let's look at number 9. We have absolute value of x is less than or equal to negative 6. So I'm going to have x is less than or equal to negative 6. And it's a less than, so it's an and problem. And then x is greater than or equal to positive 6. So let's look at a graph for this one. So I'm going to have my negative 6, my 0 for reference, and my positive 6. So the first part of it, x is less than or equal to. So we bracket and go to the right on the negative 6. On the positive 6, it's greater than or equal to. We bracket and go to the right. As we can see, it's an and problem. There is no intersection. So we have a couple ways to write our answer. We can write a blank graph, and then when we write it in interval notation, we have the empty set or 0 with a line through it, because there is no solution. Let's look at the last equation. It looks a little different than the ones we've worked in the past. The absolute value is not by itself on the left-hand side, therefore we need to make it by itself on the left-hand side. So first thing we're going to do is add 3 to each side. So then I get the absolute value of 5x plus 1 is greater than 9. Now we can separate into two equations. So I can say 5x plus 1 is greater than 9. And we're dealing with the greater than, so it's an or. And we have 5x plus 1 is less than negative 9. So the first equation, when I subtract 1 from each side, I'm going to get 5x is greater than 8. On the right side, I'm going to get 5x is less than negative 10. I'm going to divide here. I'm dividing by a positive number, so I don't change the sign. So I have x is greater than 8/5. And when I divide here, I'm dividing by a positive again. So I do not change the sign. And x is less than negative 2. So let's look at a graph. Excuse me. Look at a graph for this equation. So I have negative 2. I'm going to use my 0 for reference. And here is my 8/5. So if I have x is greater than 8/5, I'm going to parenthesis. This is just a greater than, and move to the right. And if it's less than negative 2, we're going to parenthesis and move to the left. Once again, my interval notation. I'm going to do it from left to right. We have a negative infinity, so we use a parenthesis with that. Our next number is a negative 2 with a parenthesis. We have a break in the graph, so we're going to use our union symbol, our parenthesis, 8/5, comma, positive infinity. I hope this video helped. Good luck on your homework.